Today we are going to look at how scale factor affects area. So on your graph paper, I want you to draw a rectangle that has one side length of 3 and another side length of 2. So this is a 2 and 3. We are going to enlarge, which means make larger, this rectangle by a scale factor of 3. So the scale factor is just the number that we are going to multiply by the side lengths to get our new side lengths. It's kind of similar to the constant of proportionality. So I'm going to go ahead and I'm just going to make a table since we like tables with proportional relationships. So if this is my original shape and this is my new shape, my side lengths were 2 and 3. So the scale factor is 3, so that means I'm going to multiply my side lengths by 3 to get my new side lengths. So my new side lengths are going to be 6 by 9. So let's sketch that over here in this area. Make sure it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 6. 1, 2, 3, 4, 5, 6. If you have a ruler handy, otherwise just do your best. Doesn't need to be perfect. All right, so these new side lengths are 6 and 9. So let's compare the area. I'm going to go back to my chart over here. The area of my original is 3 by 2, or 6. My original of my new is 9 by 6, which is 54. Notice that the same scale factor doesn't work. Our scale factor was 3. 6 times 3 is not 54. What do you multiply by 6 to get 54? It is times 9. So when you are working with scale factor and you're finding area, the scale factor is not the same scale factor you used for length. So our scale factor was 3, and we square it to get the scale factor for area. So 3 squared is 9, and that was the scale factor for the area. So the scale factor that we used to enlarge it was 3, and if we square that, 3 squared, that becomes our scale factor for the area. Let's do another shape. Let's do a triangle. So we're going to do a triangle that has a base, a length of 4, and then just from the center, I'm just going to count up 1, 2, 3, 4, 5, and put a dot there. And then I'm just going to complete my triangle with my ruler or any kind of straight edge you have, or just do it the best that you can. And so this distance is known as the height of the triangle, and it's 5. So let's make a table. Well, actually, let's scale factor first. Let's use a scale factor of 2. Okay, so let's make a table. So I have my original shape and my new shape. And so my base was 4, my height was 5. My scale factor is 2, so that means I'm going to do times 2 for both of these dimensions. So that becomes 8, and that becomes 10. So let's draw this. The height is going to be 10. So I'm going to start up a little bit higher. I'm just going to estimate here. And hopefully this will work out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my base is going to be 8. So that means I'm going to go out 4 on each side. and then I'm going to connect. So this is a shape that's enlarged by a scale factor of 2. So our height is now 10, and our base is now 8. Now let's talk about the area. We find the area of a triangle by doing base times height divided by 2. So for our original triangle, that's 5 times 4 divided by 2, which is 20 divided by 2, or 10. So for our table, let's write the area. The original one was 10 square units. So then on my enlarged one, again, it's base times height divided by 2. So 10 times 8 divided by 2 is 80 divided by 2, or 40. So on my table, I'm going to write 40. Notice again, that's not the same scale factor. It's not times 2, but it is times 4. And if we take our scale factor of 2 and square it, it is 4. So for our area, the scale factor is actually the scale factor squared. So 2 squared is 4. And let's do one more. Let's do a rectangle that is 5 by 10. So I'm going to go 5 across and 10 down. And let's use a scale factor of 1/5 this time. So a scale factor of 1/5, I'm going to make my table inside my rectangle just so that it stays on the camera. So my original and new, my dimensions were 5 and 10. So to find my new dimensions, I'm going to multiply by my scale factor, which is 1/5. So 5 times 1/5 is 1, and 10 times 1/5 is 2. So I'm going to draw my new shape over here. It's going to be a 1 by 2 rectangle. Not a very good rectangle, but a rectangle. 1 by 2. Notice that it shrank. Why do you think it shrank? It shrank because the scale factor is less than 1. When your scale factor is greater than 1, it gets larger, and when it's less than 1, it shrinks and gets smaller. So let's look at the area and see if the same thing holds true about the scale factor. So the area of our original was 5 times 10, or 50. And the area of our new one is 2 times 1, or 2. So 50 times 1/5, that would be 10. So 1/5, again, is not our scale factor. But let's square 1/5 and see what we get. Because on the other problems, when we squared the scale factor, it ended up being the scale factor for our area. So 1/5 squared is 1/5 times 1/5, or 1/25. So that should, in theory, be our scale factor. So let's check it out. If I take 50 times 1 over 25, I'll make that 50 over 1, I get 50 over 25, which is equivalent to 2, and that's our new area. So our scale factor here was actually our scale factor squared. So times 1/5 squared, or 1 over 25. So when you are working with scale factor, the scale factor itself works for length, but it doesn't work for area. To find the scale factor for the area, you square the scale factor that was given for the length.